Hello, my name is Frida Huerta Sanchez. I am working on hydrothermal synthesis of a bi-FeO nanocomposite for dye degradation. Introduction. Water pollution caused by synthetic dyes from textile and industrial activities is a major environmental concern due to their toxicity, persistence, and resistance to conventional treatment methods. In this context, metal oxide nanocomposites have emerged as sustainable and highly efficient alternatives for pollutant degradation. This study focuses on the hydrothermal synthesis of a bi-FeO nanocomposite, combining the unique properties of metallic bismuth and iron oxides to enhance catalytic activity. Structural and morphological characterization of the material, as well as its performance in the degradation of methylene blue dye, highlight its great potential for wastewater treatment applications. Objective: to develop and evaluate metal oxide nanocomposites based on bi and Fe for the efficient degradation of methylene blue dye. Methodology: the molar ratio of Bi and Fe is 1:1. Bi, No, 5HO and FeCl 6HO were dissolved in HNO. Ammonium hydroxide was added dropwise to the solution until the pH reached 10 to 11. The obtained sediments were washed until the pH reached 7. Then dried at 80 degrees Celsius for 24 hours. Polyethylene glycol and NaOH were dissolved in distilled water and stirred for 1H. The previous solution was transferred to several autoclaves at 180 degrees Celsius for 72H. The obtained black powder was centrifuged, washed, and dried at 60 degrees Celsius for 24 hours. At the top, the final product can be observed: shiny black powders that possess magnetic properties. Results: scanning electron microscopy (SEM). At the red pointy spherical figures marked with an arrow are mostly metallic bismuth, which are in turn coated by iron oxides. At the blue point in this phase, Fe and O are present, with a proportion of FeO. Magnetite FeO is observed in the form of octahedrons. As its name suggests, it possesses magnetic properties. Infrared. The spectrum matches that of an inorganic metal oxide. The relevant signals appear in the low-frequency region below 1000 cm, which is due to the metal-oxygen vibrations. There are no significant signals from organic groups or contaminants. X-ray diffraction (XRD). In XRD, a diffractogram was obtained in which substances such as Bi 00005, 0519, FeO 00033, 0664, and FeO 01075, 0033 were identified. Once the possible compounds present in our sample were determined, crystallographic cards were consulted to obtain more precise and consistent information. Evaluation. Feature Graph 1, Graph 2. Absorbance trend. Progressive and uniform decrease in absorbance over time. Rapid decrease in absorbance in the first minutes, with later stabilization. Main peaks. Two prominent peaks around 240 nanometers and 290 nanometers, with a slight decrease in intensity and minimal shift less than 5 nanometers toward shorter wavelengths. Two similar peaks in position, approximately 240 and approximately 290 nanometers, at the start, with a more evident shift, approximately 5 to 10 nm, toward shorter wavelengths during the reaction. General interpretation. The spectrum indicates a gradual degradation of methylene blue, with a progressive decrease in absorbance and a slight peak shift, suggesting changes in the dye's electronic structure due to catalytic photodegradation. The spectrum reflects a faster degradation in the early stages, accompanied by a more noticeable blue shift, shorter wavelength, indicating a faster breakdown of methylene blue chromophore bonds. Conclusions. Spherical nanostructures of a BiFeO composite were successfully synthesized via the hydrothermal method, demonstrating promising potential for dye degradation in water. However, the current performance is not yet optimal. Ongoing work focuses on improving particle morphology and size to enhance catalytic efficiency and achieve more effective pollutant removal in aqueous environments.